Hello again, everyone. It's now time for our next section of our factoring practice test. So we're starting with problem 11 here. So problem 11 tells us to factor. Again, the first thing we always check for is the greatest common factor. Now, 25 can only be divided by 5, and 4 can't. So we know that there's not going to be a greatest common factor here. Next thing to check for. Here we have a binomial. And 25 and 4 and x squared are all perfect squares. But it's not a difference. It's not a subtraction. So we're not going to be able to use our difference of squares rule. If we tried and we said, okay, the square root of 25x is 5x and the square root of 4 is 2, and we did our plus and minus, that's not going to work. And again, this is why we always go back and check our answer, because we might think, oh, that's the answer at the beginning, but it's really not. So if we go back and use our area model to multiply it out, 5x times 5x is 25x squared. 5x times 2 is 10x. And then 5x times negative 2 is negative 10x. And 2 times negative 2 is negative 4. So everything looks like it might work out. 10x and negative 10x add up to 0, so they're gone. But we're left with 25x squared minus 4, which is not the same problem. So this one, since there is nothing that we could do to factor it, we're going to say this one is prime. So we are done with that one. So be careful. It looks like a similar problem, but it is not the same thing. So it is not going to be this. All right, in problem number 12, we have 4x squared minus, and this is really a 1x, minus 3. So there's no GCF for 4, 1, and 3. And since our a value, the value in front of our x squared, our leading coefficient, is bigger than 1, we're going to be using our slide and divide here. So our first step here is to slide. We need to multiply the 4 times that negative 3 there. And that gives us x squared minus 1x minus 12. That's slide. Now our next step is to factor. So we need two numbers that multiply to give us negative 12, but add to give us negative 1. So again, we could list out our factors here. And since they multiply, give us a negative, that tells us one's going to be negative, one's going to be positive. So I have 1 and negative 12, or negative 1 and 12. Now those don't add up to give us negative 1. I could have 2 and negative 6, or I could negative 2 and positive 6. Negative 2 plus negative 6 gives us negative 4. Not going to be that one. I could have 3 and negative 4. Or I could have negative 3 and positive 4. One of those is going to be the one that works. Since this adds up to a negative, the bigger of the two numbers needs to be negative. So we have 3 plus negative 4, 3 minus 4. And those are going to be the ones that work here. So 3 and negative 4. So we did our slide, we did our factor, we have to write it as x plus 3, and x minus 4. Slide, factor, now we're going to divide. When we divide, we're dividing by the number we slid at the very beginning, that leading coefficient, and that's our 4 here. Now we're going to reduce, we got to simplify those. So here, 3/4 can't be reduced, so it's just going to stay 3 over 4. 4 over 4 can be reduced. 4 divided by 4 is just 1. And our very last step here is going to be to swing. So when we swing, we're going to take this denominator and move it to the very front. And that's going to give us 4x plus 3 and x minus 1. And when we look at this, we have 4x plus 3 here, and x plus 1. Be careful. C looks the same, but the signs are switched. That's another reason it's a good idea to go back and check your answers. All right, number 13 here says to factor completely. I'm noticing right here 30, 24, and 60 are all even. That's going to tell me I have a GCF I can take out. So let's go ahead and work with that upside down birthday cake method. 30d to the third minus 24d squared plus 60d. Alright, so all three of these numbers are even, meaning I can divide by 2. Oops. 30 divided by 2 gives us 15, d to the third. 24 divided by 2 gives us 12. And 60 divided by 2 gives us 30. Alright, now they're not all even anymore. I can't divide by 2, but 15, 12, and 30 can all be divided by 3. 15 divided by 3 is going to give us 5. 12 divided by 3 is going to give us 4. And 30 divided by 3 is going to give us 10. And notice those d's haven't changed. We haven't done anything with those yet. Alright, now 5 can only be divided by 1 and 5. 5 is not going to go into 4, so we are done with that part. But the next thing I notice is all three of these have a d. And remember, if there is no exponent, we go with the lowest. Or sorry, we're going to write a 1. And to factor, we're going to take out the lowest exponent. So 3, 2, 1. We're going to take out just d to the first, or d. Now I had 5d to the third. So that meant I had 3 d's here. When I take out a d, I'm left with only 2. And in the middle, I'm left with 1. And at the end, I took that d out, so there's no more d's there. So this problem, our greatest common factor comes from these outsides. We took out a 2, a 3, and a d. 2 times 3 is 6, and we have a d. So our greatest common factor we took out was 6d. And we were left with the leftovers down here at the bottom of our cake of 5d squared minus 4d plus 10. Now, normally I would go ahead and do slide and divide and see if I could factor that anymore. But when I look at this problem and my answer choices aren't factored anymore. There's no 2 sets of parentheses. All that was done in this problem was taken out at GCF. So when I match up my answers, answer choice C is what I had here. All right, number 14 says factor completely here. So 20 and 12, 25 and 15. There's not going to be a GCF here. 15 can only be divided by 3 and 5. And when I look at the others, 20 could be divided by 5, so could 25, but 12 can't. And then 20 and 25 can't be divided by 3, so there's no actual GCF here. Since there's 4 terms, we're going to do grouping. We have to draw our line down the middle, divide that problem in half. Now for each half, we're going to have to find our greatest common factor. So I have 20 into the third plus 12 in the squared. Now both of these have a 2 in common because they're both even. So I'm going to take out a 2. 20 divided by 2 gives me 10 into the third. 12 divided by 2 gives me 6. Now both of those still can be divided by 2. I'm going to take out 2 again. 10 divided by 2 gives me 5. 6 divided by 2 is going to give me 3. So it looks like I'm done with my numbers here. Now I just have to look at my variables. So I'm going to take out the one with the smallest exponent, which is just n squared. And that leaves me with 5n plus 3. So when I look at my GCF here, I have to multiply these together. I get 4n squared, and that's what I'm pulling out. And I'm left with that bottom row, that 5n plus 3. So that's half the problem. For the other half, we're going to do the same thing to the other side. So 25n plus 15. Both of these can be divided by 5. So that leaves me with here 5n plus 3. And notice I have the same thing now that I had at the bottom of my cake before. That's a good thing. We need it to be the same because that's going to mean our parentheses are the same. So we need to take our greatest common factor, take that out, and that was a positive 5. And then left, we have 5n plus 3. So we want those parentheses to be the same. Now, one of the sets of parentheses in our answer is going to come from those GCFs, the 4n squared plus 5. The other is going to come from the 5n plus 3. And when we look at it, there's no GCF in this set of parentheses, none in here. So we are done. We factored as far as we can go. So our answer here is 4n squared plus 5 and 5n plus 3. And again, we could use our area model or boxes or FOIL to multiply that back together to make sure that we got the right answer. All right, now we have a word problem. So the long side of a rectangle is n plus 3 units, and its area is 5n squared plus 19n plus 12. Find the width. All right, so we know, first of all, it tells us, the area of a rectangle. If we're talking about area equals length times width. So two things multiply by each other. All this really is a factoring problem. And when we get our answer, we're going to have two sets of parentheses. One of them is going to be the length, the other is going to be the width. So let's factor this problem. We have 5n squared plus 19n plus 12. And there's no GCF here because 19 is a prime number, can only be divided by 1 in itself. And since our a value, our leading coefficient, is greater than 1, this is going to be a slide and divide problem. So we're going to take that 5 and multiply it by the 12. This is our slide. Let me write down my steps. And that gives us n squared plus 19n plus 60. That's our slide. Now we're going to factor. So I need two numbers here that multiply give me 60 and add to give me 19. So again, if I want to use the calculator, I can for now. So I'm going to press y equals. And the number one to multiply give us is 60. So I'm going to do 60 divided by x and the y equals. And then do second graph. Now, let me get this back starting. All right. So I need two numbers side by side, and they're both positive to add to give me 19. 1 plus 60 is 61. 3 plus 20, 23. 4 plus 15, that gives us 19. So 4 and 15, they multiply to give us 60, but add to give us 19. So we have 4 and we have 15. So as part of our factoring, we need to write it in the two sets of parentheses, n plus 4, n plus 15. So that's our slide and our factor. Now we're going to divide. So again, we divide by the number we slid at the very beginning, which was our 5. And then we are going to slide, factor, divide, reduce. That just means to simplify your fraction. Now 4 over 5 can't simplify, so we're going to leave it as 4 over 5. 15 over 5, 15 divided by 5 is just 3. And then our last step is to swing. Okay, so we're going to take our denominator and swing that in front of the numerator. So we are left with 5n plus 4 and n plus 3. Now notice in the original problem, it tells us the long side, our length, is n plus 3. So this is our length. And the other one that's left, this 5n plus 4, that is going to be our width. And that's just our answer there is 5n plus 4. So all that was a factoring problem. Just the two sides multiply together. One's the length, one's the width. And we didn't even need to use the n plus 3 at the beginning. We could just factor and solve. So number 16 here, this is another factoring problem. And here, when we look at our problem, there's no greatest common factor. 2, 1, and negative 6 can't all be divided by something. And since our leading coefficient here is greater than 1, we're back to another slide and divide problem. So our first step again is slide. So we have p squared plus 1p minus 12, and this is looking pretty familiar to a problem we actually did a few minutes ago. So our next step is factor. And when we factor, we're looking for two numbers that multiply, give us that last number at negative 12, and add to give us our middle number, that 1. So in this problem, when they multiply like this, and look, this is like number 12, except we have different numbers. So number 12, here's factors that give us 12, and they have to add to give us positive 1. Now before we were looking for numbers that give us negative 1, so it was 3 and negative 4. But now we're looking for ones that give us positive 1, so it's negative 3 and positive 4. So it helps to kind of go back to old work as well. So we factor, we have p minus 3 and p plus 4. So we slide, we factor. Now we divide. So when we divide, we're dividing by the number we slid at the beginning, that 2. And then we're going to reduce. We're going to simplify. 3 over 2 can't be reduced, so we're going to leave it as 3 over 2. But 4 over 2 can be reduced. 4 divided by 2 is 2. And then our last step, we are going to swing. So we're going to take any denominator we have and pull it in front of the numerator, swing it in front. And that's going to leave us with 2p minus 3 and p plus 2. Again, be very careful of the answers because there are some that are very similar here, just the signs are different. So notice in C and D, these both have p plus 6 or p minus 6. Those aren't going to be it. So in A and B, we're looking between those. We have to find the 2p minus 3. And that's going to be A. So again, B was really careful, or really similar there, so be careful. All right, number 17. Find one of the factors of 100x squared minus 40x plus 4. All right, so number 17 is kind of a weird problem. I don't really like it because